Dear viewers, very happy morning to all. So today's session we are going to see that the phase shift full bridge controller or phase shifted full bridge converter we are going to use for charging the battery. Nowadays, the battery, electrical batteries, which can be charged uh, through the isolating mode. So, in this way, we are going to charge the battery through the PV, power electronic PV. Again, that is the 2.5 kilowatt. That is the PV system. First, we have assumed. Again, it may be uploaded or upgraded into the 87 kilowatt, the 100 kilohertz switching frequency, and silicon carbide based devices which can be going to configured, right? So the step by step operation in the phase shift controller we are going to see. This is the first PV array. That PV array has been simulated here. This is the PV array. So the each array, the number of series, number of parallel element, which may be combination of the series 30 and 12. So based on that series and parallel combinations, we are obtained that the maximum that is the power rating and 750 watts per meter square irradiation we are going to obtain that around 58 plus. Again, if it is irradiation is increases, that is the 76. Again, we have going to uplift of that the batteries we have going to be implemented, right? So this is the way of the source unity which can be connected. Again, the incremental conductance based MPPT. Again, PV voltage PI controller. So these are all the outer loop controller. First, we are going to see the power circuit. This is the source circuit. Again, we are going to see the power circuit. This is nothing but the H bridge 4 MOSFET is there. The output of the PV, this is that diode that is to avoid the that is feedback signal, or if you are going to power reversal, to avoid the power reversal, that is this type of diode is maybe going to connector. But real world, that is the number of group of parallel diode is connected. Again, it may be connected in the H bridge. So the inside of the H bridge, we are going to connect the high frequency transformer. This is the high frequency transformer. Again, this is the universal bridge in the diode bridge based rectifier. The rectifier output which has going to given into the small that is LC combination of that filter. This is one high type load is connected in parallel to avoid this that is anti-parallel current source which may be going to act as a load. So again, this may be going to connected with that the battery. The battery achieves the capability of 360 volt and 250 AS, which means that is 360 into 250. We are going to assume as the for 87, that is this is the 87 kilowatt of the battery system which is going to be charged by the this PV systems. Okay, now we are going to see the basic operation of the converter. Again, the phase shift operation we are obtained through the controller. Again, the PSP transformer, which is high frequency transformer. DC voltage bus. This is the DC voltage bus which can be regulate the DC voltage based on the that is the requirement of that the battery charging level. Okay, so this is the 250 Ah battery. Initially, that is 52 amps. Again, 4 hour, that is 0.2 C. But if we are going to increase that the current in the different range and different level, we are going to see. So how the different range of that current we are going to give an input. see, this is the charging level current. First, that is 95 amps we are going to feed. Again, that is the 105 amps. Again, 135 amps we are going to be feed. So the actual current we are going to limit it to the 125 amps. If the 95 amps, that is the current is increases, again 105 amps, then the current is increases. If the setting will be going to beyond the level, that is 135 amps, but the output current is limited to 120 amps, because 0.5 C is the that is the maximum charging current. So this point here we are going to see the specific that point, right? Different point. This is the scope which can be going see, that is the results, that is V bat, that is battery. Again, that the current, this which may be going to indicates that the that is this is 100 amps scale. Again, small oscillation which may be going to present. So this is the 95 amps we are going to maintain that the controller. After that, we are going to maintain the 105 amps, that is maintained by the controller. Again, it may be increases with the 135 amps, but 0.5 C, 0.5 C, that is we want to maintain the 0.5 C. For that purpose, we are going to give the 120 amps. Again, that the SOC of the PV battery is continuously increased. If the charging going to be reaches the 100%, again the system which can be automatically tripped. So we want to see the another scope for this action for this scope. So that is the phi, that is short circuit level, or the phase shifting action. How much phase shift is occur that initially. So again, that is voltage bus current on the bus, which can be multiplied in the power on the bus, which, you know, how much of that power is supplied to that battery. Again, that is the voltage and the current. This is the voltage which here the charging purpose we are connected in the reverse for measurement, for identification purpose. This is a positive voltage supply which may be going to connected in the negative which may be going to connected in the positive. So for that reason, which may be going to give that the negative voltage, but it may be give the constant that is the charging level voltage. Again, we have going to attain that the different current. So what is that the required current which can be changed from that ampere, 95 ampere, 105 ampere and 120 ampere level, right? So this is the another way. Again, we are going to see the control circuit. This is the basic control circuit of that phase shifter CV PID based charger. Here this is the entire configuration is to be given for CC mode of regulation, SOC and BAT charges. Next CV is the constant voltage mode. Again, the what are all the inputs, then what is the outputs which is given to the power circuit. Again, this is that the measurement, what are the measurement of the filter. This is the PID gain. If we are going to change the gain, based on this gain we are going to easily settle the system. Again, it may be the persistence state for the different status of the CC and CV block. Filter measurement. Again, the soft start ramp up, the immediately it is not raised to the maximum magnitude. Slowly it may be going to reaches on its full magnitude. So this is the another state transition time. Again, active state transition control, the direction our anti wind up for the PID controller which may be going to implementer. Again, slew rate action will be taken. This is the phase shifter. Finally, the first phase shifter which are going to be obtained. So the most probably there is the different converters they are using for the PV, but this phase shifted converter, high frequency converter, phase shifter converter is specifically used for the EV charging purpose. Why? Because that is phase shifted full bridge converter which can be used for, this is the isolation mode and high power transferring purpose. Okay, this is the entire simulation which is available, and the description we are going to implement what is the overall information of the simulation. Right? Thank you. We will see on another video.